I figured out how to press the button. Hello. Welcome to another. I'm sorry, I don't have a cool intro video for y'all. This wasn't the system administrator show, and I didn't feel like it was fair to ape their video. So, welcome to another episode of Scalable Multiplayer Game Design. Maybe we should start calling it often delayed multiplayer game design. I'm Erik Jacobs. I'm your host today, joined by Roderick Kieley and Mr. Jason Dudash, who decided that only his last name is important. It's fine with me. I don't object. So yeah, it's been a minute since we've last visited with y'all. I should probably open the stream chat. I don't even know where to go to see that in here. Private chat. Where is this app hide? Close the design window. Captions. Brand folder. Design, captions, QR code, music, chat. Aha, I found it. Woohoo! It's at the bottom. It's the last place I looked. Surprise, surprise. So yeah, it's been a minute since we've last joined with y'all. There's been a bunch of interesting developments since then. So Roddy, if you want to talk about the server Godot 4 upgrade, because you did most of that. So there was a Godot 4 upgrade for those who haven't noticed. Godot 4 has come out. It has gone GA. It is no longer beta. They're even actually at 4.1. And so Roderick took a stab at upgrading the server to 4 initially. How did that go?
It actually was relatively smooth. Like there's an automated process that happens first to migrate your 3 version project to version 4, kind of in like the big picture, where the system itself handles those things that are known, that it can identify, that it can do for you. And then there's a bunch of other stuff that's left on the table. Maybe things you were doing that were legal, but not necessarily best practice. And I think we've had a number of those.
That sounds like a dangerous conversation about legal, but not legal,
yes,
but
yeah.
acceptable.
I think best practice only applies in the software world when it comes to that type of conversation. However, so yeah, there was some stuff to step through. I mean, it took a few hours. It took 5 minutes to do the migration, quote unquote, from the perspective of Godot. And then there were some things where we probably hadn't looked at the code in a while, or we wrote it in haste just to get it done and get it working in the beginning. And then it broke, and then it was like had this little bit of head scratching going on to see, like, hey, why did we do this, and why did it make sense at the time? And why does Godot 4 need something different? And usually, Godot has a fairly vibrant community around it at the moment. And so for all the issues that I ran into, like usually a quick Google search led me at least in the right direction, if not giving me, the solution outright. So I think overall, as far as like major version upgrades go, given that the size of our projects are not that big, I didn't expect it to be a big process. It just took a little bit of time, but there were no major headaches, which I think was a positive outcome.
Do you recall? Wasn't there like a minor weird C# headache you had?
There were, I think, some, because the version of C# moves from being based on Mono, so like the .NET framework, like version 4.7, and then in Godot 4 you can use proper like .NET Core, like I think it's
7?
.NET Standard. Yeah, it's.
Oh yeah.
I think it's
yeah.
it's baseline 6.0 C# stuff, but I think it's like .NET Standard 2.0. I forget how all that kind of interrelates now at the moment. It's all a bit complicated. But anyway, there's like a fundamental generational change in the C# runtime underneath the hood. It moves from like .NET framework to like proper .NET future stuff.
Yeah, it moved to. I'm looking at the CS proj file right now.
Yeah.
It moved to .NET 6,
Right,
.NET
there you
6,
go.
which is like proper C#.
Yeah, and importantly, like from my point of view, with my messaging engineer hat on here at Red Hat, like that was really beneficial from my point of view, because there's a new AMQP networking client that has just been created based on the new .NET Core work, which needs the new .NET runtime to run. And now that that's integrated in Godot, we can move from AMQP .NET Lite, which is the current foundation of what we have, to a brand new client from the Apache upstream community Cupid. So it's cupidproton.net, which is a brand new client that's been very focused on performance. And the existing one had a certain way of going about things that was very what they would call reactive. And the new one is very much more imperative in its style.
Reactive programming.
Yeah, reactive programming versus
Got
kind
it.
of imperative programming,
Yeah.
right? And people generally tend to be a little more familiar with the imperative style. So at some point, this will give me an excuse to try to swap out one networking layer for another.
Just
Which
in time.
just because.
Yeah. But yeah, so just to recap, right? So Godot 4 upgrade on the server, pretty trivial. There were a couple of niggles that occurred, like because some objects sort of changed minorly in how they function. So like some text things got rendered slightly differently, and then there was one weird bug that came up where we had a collision box on an object, but somehow the collision box used to behave in one way where it would move with the object. And then when we upgraded to Godot 4, the collision box just stayed in the center of the screen and the object would move around. And so you'd be like shooting missiles and nothing's happening. And you're like, I don't understand what's going on here. And I actually had to run the game in double debug mode. So our debug mode with the server UI plus Godot debug mode, like show all the things. And I was like, oh, the box is
Not moving.
Not moving.
Yeah, there was some world space thing that previously was handled, like object space, the world space transform or something there. I'm just trying to look back here now at the PR to see if I can see what it is, or what it was rather.
I don't know what I did, but I changed, which there might have been a minor PR in there where I changed like some. Actually, I could probably find it in the code. I might as well share my screen at this point. Entire screen, share my screen, switch to VS Code. Whoa, can you see my VS Code?
I can.
Yep.
Okay. Open the Godot editor, which is gonna be weird. Let's see if we can find what that was. So actually, if I do this, so here's the. Nope, it's not an assets. It's player ship. Yeah, so I think it was the click box. For whatever reason, like I'm like clicking away in the UI and it's not working right, and something happened in here where it was like yeah, I think it was this line here, the global position.
Yeah, I'm just looking at some updates. The global position in the original.
This is an issue with clicking the ship in debug UI. Yeah, there it is. How do I? Ooh, show me the commit. Yeah. Changes. Ooh, yeah. This. Open the changes. Yeah. So we never did it before, and for whatever reason, the clickbox object, which is a collision shape 2D, even though it's a child of this thing that we're moving, it decided to not go along for the ride. Maybe there's some stupid checkbox that like that should be checked that I don't have checked. But anyway, the way we fixed it was just move it to the global position of the main object. So that fixed that problem. So like you'll as you upgrade to Godot 4, you're going to encounter goofy little dorky things like that. Occasionally, the name of an object will change. So you'll have to like change a bunch of references in your code because all of a sudden that thing doesn't exist. They changed like some symbol names. I'm trying to remember.
The doubles.
Oh yeah. There's a lot of
right across the board.
So yeah, all the deltas come in as doubles now, and so there's very much float double cast conversion stuff, which probably you don't have to do in GDScript, but you definitely have to do in C#. Yeah, so like here's like all the there's just a lot of like randomly gonna cast that to a float now. Yeah. But whatever, it fixes the problem, so can't complain too much.
And I see another one here, kinematic body 2D. We're using character body 2D. So.
Yeah. Yep. that sounds right. So, Godot 4 upgrade on the server was pretty trivial. For whatever reason on the client, it was like even more trivial. I think I ran the updater and was basically done. I mean, it was almost that good. So one of the big changes that we made though is in the networking layer. And so what I'm going to do is I'm going to open a new window here. So for those who may not be familiar with the code base, Roddy, if you could put in the chat the srtgame.com URL.
Sure thing.
I'm going to pull
Let's make
up
sure I
the
get to everyone here.
protobuffs. So we are using a combination of, as Roddy mentioned previously, the AMQP Net Lite library, which is a .NET library that knows how to speak the AMQP message protocol to a message server broker infrastructure that we have. And what we're doing is we're using binary serialization via Protobuf, which is a Google project, to basically bin pack messages to make them transport better. So one of the things that we had been doing previously was in the server, I am going to go to the update player. I'm not in the right file. Server, blah, 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 blah. Yes, send game updates. Yes. So previously, what we were doing is we were iterating over each of the player objects and then sending a message. And then we would go find the missiles that are flying around and iterate over each of the missiles and then send a message. So if you had 10 ships and 10 missiles, you sent 10 messages, which is a lot of messages. And it started to lag the client because the client was spending so much time doing TCP handshake. So AMQP is a TCP protocol today. The client was spending so much time between like handshaking and like packet deserialization and all this other stuff that once you got to about like 6 or 7 players, it just annihilated the client and started lagging super bad. So not unexpectedly, that was not the right thing to do. So what we changed was in Protobuf, you have the capability of doing message of messages. And so each game event now contains multiple mini event messages, if you will, in one giant packet. For all of the players and all of the missiles. So essentially, we are bin packing a giant array of all of the things that it knows about in the game. If you want to understand part of the reason why we're doing this, Gaffer on games. So there is a technique in networking in gaming called snapshot interpolation, where essentially you send a snapshot of what's going on to the client, and then you like wait a while and you send a new snapshot, and the client will buffer up a few of those, and then it'll interpolate between the last update that it got and the current update. So the ship was here, the ship's supposed to eventually be here. In the next however many frames, I'm going to linearly or some other interpolation technique between them. And if you go through this post, it's really good. And this browser appears to be frozen. The videos don't play automatically, but it's got a bunch of different videos that talk about like how much network it uses and all this other stuff. But basically, it's a rough guide on how to do snapshot interpolation. I did find, interestingly, a Godot repo for snapshot interpolation, but it was like Godot 2. And it was using like direct UDP communication and all this other stuff. It's valuable. It was good. Let's see, I wonder if I can find it again. Let's see here. Go snapshot interpolation. It was a GitHub repo somewhere. Was it this crazy thing? Yeah, so there's like this post that goes into a bunch of detail on how to do it. I'll put this in the chat for anybody that's interested. I lost the chat just now. There we go. That. So there's some examples out there of how to do it, but the TLDR on how we did it was, so I modified the message structure to be a message of messages, and then in the server, essentially what we do is, let's see, let's walk through the code here. So we create a new base update event, which has the type of update, unsurprisingly. Find an array of all the players and the missiles that we know about. And then, assuming the count is not 0, so like we actually have some players, we keep going. And so for each player, increase, iterate over the players, increase the index, if you will. Create a game object from that particular player, and then in the update event, in the game objects array, add the object that we just created. If we go to look at this method, it's pretty simple. It instantiates a new empty object. It sets the type to player. It fetches the UUID of the player. This happens to be in the playership code, so the UUID is self. I don't use this by convention generally. Grabs the position, which we're sending as integers, the rotation, the velocity, how many hit points the player has, returns the game object back to the calling method, which is here. So add to the array, reset the index. Oh, you know what? I don't even actually use this index. I get rid of that. Look at that. You helped me troubleshoot. Pair programming for the win. There was a reason why I had that index somewhere, and I don't know why. Then we do the same thing for the missile, create an object for the missile, add it to the game objects array, and then ultimately we send that whole event. So we've packed the whole event. Interestingly, if I go to references, oh, you know what? I thought I wrapped that in a thing. I think actually I do it at the very beginning. Yes. So there's this weird time calculation, which basically is the buffering on the server side. So if you look at what we do, we say, okay, what time is it now? What's the difference in the last time we sent a message and now? And then if that time is less than the frame timer, just immediately exit the update section. Hey, we're not sending a message because the last message was sent however many milliseconds ago. If I look at the definition of frame timer MS, I've got it set to 50. I don't remember what the math is on that one, but it's like 50 millis. I don't know how many milliseconds are in a frame when there's 60 frames per second, but it's some number of frames. It's like a couple 10. I don't remember, but I did some testing. You'll do some testing. You'll figure something out. So every 50 milliseconds, we're willing to send a new message. And then, of course, we update the last sent time to the time that it is now, and then finish with actually sending the message.
And you only log that like on super verbose mode, right? Because we definitely don't want to be.
Yeah. We only there's a lot of stuff that only gets logged on verbose, because if you and when you run the server or the client in verbose, it's just like message spam forever. And there is a performance impact when there's that much message spam. So that's the basics of like the snapshot interpolation on the server side. The harder part marginally is on the client side. But again, just to recap what we're doing. So we calculate the time difference. If the time difference is enough, if it's been long enough since the last time we sent a message, we go ahead and we iterate over all the objects. We stuff them into this big array of objects, and we send that big array of objects as a single message. I did some calculations locally to figure out like sort of the bandwidth that we're consuming. And so essentially we look at the message event bytes for the whole update event. Who owns this function? Is this? It's just a very lame function that just returns the length in bytes of the object. I noticed that I'm actually instantiating and serializing the object to calculate that, which probably is painful.
Less than ideal.
Yeah, there's got to be a better way. So if anybody knows how to calculate the length of a protobuf, there's probably a way. Because update event is a protobuf, I think. Game event is a
Yeah,
Anyway.
and looking at it through the broker web console, it looked like each message was 487 bytes.
Which is not a lot. Like that's a pretty tiny. Well,
Yeah.
for however many players and objects you had.
Right.
You know.
Right. That was correct.
We had done some calculations back of the envelope in GitHub. In the client? No, it was in the server. Or was it in the protobufs?
And like that's without deltification or anything as well.
Or was it in the
right?
game design? Do you remember where the GitHub issue was that had the
Good question.
protobuf
a look.
calculation? I think it was the game design repo. It was in here, and I think the issue was closed. Restructuring of proto messages. Yeah, here we go. So I did some terrible math, and no, this is not the place where I did the terrible math. Where was the place where I did the terrible math? I think this was even before. Maybe I didn't close the issue. Oh, browser. Client server heartbeat, data grid, dead reckoning, ship collision. This is someplace else. Let's look someplace else. Let's try the server repo. Server. Choose. Nope. Wow, there's some cool old stuff in here. Swap stomp for AMQP. Look at that.
That definitely goes back a ways.
Yeah. Nope, it's not here. Is it in the protobuf repo itself? Ship Wars. Oh, I guess Ship Wars got updated.
Yeah, it's not my history either, unfortunately.
It's not what?
It wasn't in my Google
Aha,
history.
here
I
it
was
is.
looking for it.
Got it.
There you go.
Okay.
Good. Right, so here you were calculating like
yeah,
what the up or
so
down
back
was
of the
gonna be,
envelope
right?
math, which is based on some post. I think it's this Stack Overflow thread.
It breaks
that's
down the
linked here.
size of each type. Right?
Yeah, and so I went through each. Then I'm like, okay, an enum is 1 byte, and blah blah blah. And so like the worst case scenario was it ended up being like 73 bytes per player or whatever. And so anyway, more math, and it was like 0.02 megabit. Like it's just tiny amount of bandwidth.
Yeah.
So it's really not a problem.
Yeah, and I think at the time when I was running the server, I was somewhere between 1 and 14 clients when I was looking at it. So what I noticed is there's a TTL set on the messages in the code.
Yes.
And a bunch of them timed out and went to something called the expiry queue. And so there was like 1,400 messages in the expiry queue after I'd left the clients running on my machine for a while. But now, to be fair, I had the server, the broker, and 14 clients running on my laptop. So the laptop was pretty busy trying to, keep all that going, along with, of course, 2 instances of Godot and an IDE for the code. So it was healthily being crushed. So it's understandable that some of the packets just didn't quite make it.
Yeah, and so only create and destroy events are mega important and should never get lost. But if it's not a create event or a destroy event, we don't care if it gets lost, especially now that we're sort of doing snapshot interpolation. So basically, I should probably actually set this number to match the frame timer. But essentially, if a message doesn't get picked up within 50 milliseconds, the message broker, which holds the messages, will just discard it. And then, as Roddy said, it goes into the expiry queue. And then I also added this creation time metadata because we use that for lag calculation on the client side. So on the client side,
Yeah, I found that lag calculation actually very handy because you can see kind of it. I think it's like there's a post at 1 second intervals, and then post what the current calculated
yes,
latency is, and you
yes,
could see as I ramped up from like one client to 14, you could see that there was a couple of places where around maybe 5 or 6 clients it went from in my given situation went from like 55 to 60 milliseconds to like 80, and then again when I crossed over like into like maybe 10 or 12 clients, it went from like 80 milliseconds to like 120 up until and it stayed roughly in that ballpark until I hit 14, at which point my machine probably
it
really
was
couldn't
dying.
handle a whole, but yeah, it was dying and couldn't
Yeah.
handle a lot more.
So here's where we process the game event that comes in, and so a bunch of what ended up happening. Actually, where's this get called? Yeah. Okay. So even further back. So when a game event is received by the messaging system, we acknowledge receipt of the message, which sends something back to the broker, which we could probably get rid of. I think maybe, I don't know. Anyway, we deserialize the message. We say, okay, if it's an event, if it's an update type, we look at the sequence number. And so the sequence number is really important for the snapshot interpolation. In TCP and with the broker system that we have in place, it's nearly impossible to get a message out of order. In UDP land, which is traditional game networking, like you might get messages out of order all the time. And so all we're doing here is saying, okay, as long as the message that just came in is newer than the message that I know about, I will care. If the message that came in is not newer, then I'll debug log some weird, like explain why it happened that way, and then abort. So if the message is newer, we update our picture of the world to be the newest message sequence number, and then we move along. And so then I begin to do the lag calculation. So I say, all right, I don't know why I called it DT, message date time, I guess.
Or
So
delta time.
yeah, something like that. So I probably should have used the full word. Like I'm still stuck in like old school computer land where it's like, no, variable names should be short. So if the message properties are null, we can't do this because we're relying on a null. So this is a simple check. There's probably a smarter C# way to do this, but this is my stupid person way to do it. So set the delta time to be the creation time that was sent along in the actual message. And then I don't remember why I needed to use this time to Unix milliseconds. It has something to do with the whatever this nasty thing is. This helpful message tells me creation time is a date time. So to cast through an offset, we can use the Unix time easily. There may be a better way to do this. If the properties are null, then we set the DT to 0 because we don't know what it is. Then we say the local date time is now, and then the date time differential or difference, I should say, is the local minus the message. If we're in verbose mode, we log some stuff. We create a tuple of the message that was received and the DT, because we're going to use the DT for lag calculations inside the message processing. And then we process the whole tuple. So that was a big update to this function, was to make it handle a tuple properly. So extract the event from the tuple. Okay, egeb is the tuple's egeb. Process the game event. If the game event is create, here's a handy message. Create messages should only have one object, but we should still iterate over them anyway because somebody might have done something bad. If we create a player, do the player create. If we create a missile, do the missile create. These are pretty lame. If it's a destroy, go ahead and put stuff on the destroy queue. If it's a retrieve, this isn't implemented. If it's a update, this is where the magic happens. So we put onto the queue the message and then the time diff. So let's look at the queue processing, which is in the game. process player updates.
And
So,
Eric, just
yes,
to
sir.
like make sure I'm tracking and everybody else following, this is like every message hits this loop,
Every time a message is received, it
regardless of the
causes,
content of that.
regardless of the content, the first place it lands is process game event. So I should be partially clear. Anytime a message is received on the game event queue, we have multiple message queues associated with the game. There's security queue, and then there's game event queue that the clients care about. And then there's a command queue where the clients send, like I'm pressing the left arrow, I'm shooting my missile. So whenever the client receives a message on the game event queue, this initial processing gets happened of like figuring out what type of a message we received specifically. Like, is it an update? Is it a create? Is it a whatever? And then we have these internal queues, like literal C# queue objects, system collection, concurrent queue, where we hold things. And then in the game loop, so all of the server connection stuff, this is all like async, right? So a message can appear at any time in the middle of anything happening, asynchronously. C# handles via threads and all the other fun stuff that I can't explain. This happens. And so in the game loop, we have, let's look at the process, right? Process happens theoretically every frame. Process the game event buffer, and then iterate over all the queues. So the game event buffer processor thing basically does something similar to what the server does. It says, if we have enough messages in the buffer, if we don't have enough messages in the buffer, don't do anything. If we have enough messages in the buffer, pop one of them off and then process it. And so if you remember from previously, like we queued that whole game event, which was like the array of lots of objects and the time that we calculated already. So here we're basically popping that event off the queue. We are looking at the time diff, and then we go over each object in the array and figure stuff out. So I don't think new tuple is required since we just created the tuple above. Okay. So what do? We check if the update has a valid UUID for the object. If it's an invalid UUID, if it's a UUID that like is null, we don't know what to do with that, so we don't do anything. Then we look at what type of object it is. If it's a player, we put that specific player object into the queue, and then we put the missile object into the queue. So there might be a better way to do this, but essentially what we're doing is we receive stuff from the server, we temporarily put it in a queue, which is this game update buffer. Every frame, we look at the game update buffer and we say, is there enough stuff in the buffer to move forward? If there's enough stuff in the buffer to move forward, at that point, we pull all of the objects out of that buffered event and put them into the respective queues for processing. So if we go back to the process function, this code is getting really unwieldy. We need to break it up into multiple files. Every frame we do process the creates, process the updates, process the missiles, process missile destroy. So let's look specifically at process player create. I have a feeling that a cat is going to end up on the counter here momentarily. Process player update. So here's where we dequeue a game object and the time the message came in to the system. If for some reason the game object is null, like that's weird. Here's the cat. Hi, cat. This is Chet.
We must pause
He
all coding
Zoom
for
bombs.
cat petting.
Yeah. Pause all coding for cat petting. Okay. So if the message is null, like that's weird. We should skip. Shouldn't this be return and not continue?
It's going to continue. It's going to go to the next.
Oh, the next object. Good call. It is correct. Okay. So dequeuing the player update message, do another time calculation. This is where we can. You see this? He like paws at me. Like, no, you should be petting me. We do another calculation of times. We figure out the total lag, and we increment the number of updates that we've processed. I think we use this updates process for some other log message later. So finally, we get to the point where we say, okay, this ship, we're going to figure out which one it is from the game object, and then we are going to update using the data in the game object, whatever that ship is. So essentially, every frame, while there's stuff to dequeue, we go ahead and we process the player updates. So in this particular code, we actually have no knowledge of the fact that it's snapshotted or buffered or whatever. It's just, hey, is there anything in the queue? Let's go ahead and do the update that might be queued. So if we look at this update from game event buffer, this is actually very simple. It's just updating the targets for where the object should be. You know, you're in a very awkward place for me to pet you. Here, let's try this. So interestingly, one of the things we found, no, don't do that. You can't come in my lap. No. Interestingly, one of the things that we found was with this system, because there's buffered messages and because we process the destroys immediately and we don't buffer them, you would have this weird sequence of, I get an update, I get a destroy, I get an update for the player that's already destroyed. And we had code that basically said, well, because a client can join at any time during the game, if we receive an update for something we don't know about, we should create it. And so you would have this weird scenario where an object would be there, it would be destroyed, and then immediately in the next frame, it would get reinstantiated in this like weird meta state because the server doesn't know about it anymore, but the client thinks it exists, and it was just all hell would break loose. So it was bad. So I implemented this marked for destruction check where basically if we receive an update about something that we think is in the process of being destroyed, just ignore the update and return. Hit points do not get lerped. There's no interpolation of hit points. You're alive or you're dead. I have some verbose messaging for like what the current position of the player is and what the incoming position of the player is. And then basically we have these target position, rotation, velocity. And then if we scroll down inside the player and look at the player's process, and again, remember process happens roughly every frame. We run this remove player check, which basically looks at some time stuff, checks if we're marked for destruction, checks if any of the animations or sounds are playing, and then ultimately finally like removes the player from the client knowledge and then literally deletes the thing from Godot. Then we check the missile reload. So this has to do with the fact that you can only fire once every so often. We update the hit point ring. And then we come down here and we say, all right, well, there was a weird issue with the client where as you're spinning the ship, you get past a point and the number flips from negative 180 to positive 180 because Godot doesn't use like 360 degrees. It uses negative 180 and positive 180. So what would happen is the ship would rotate. And then because we're lerping, because we're interpolating between the target and the current, well, the lerp between negative 170 and positive 180 is like all the way around the other way. So the ship would do this and then it would be like, woo, and then come back to where it needed to be. And so basically this is an ugly hack to essentially check if your target is more than 350 degrees out. So you're crossing the negative barrier. And if you're more than 350 degrees out, just immediately set the new rotation to the target. There's probably a happier way to do this because it's still, there's a little bit of a hitch when it rotates past, but whatever, it works well enough. Otherwise, interpolate between the current and the target. The velocity, we do the same thing. And remember I forget what we're using. I don't think we actually use the velocity for anything in the client because we're not using Godot physics. So this might be completely useless. And then lastly, we lerp the position of the client. So effectively what happens is like, so if we rewind all the way and review, the client gets a big bucket of stuff in an array. It buffers it. It checks to see if we should do something with the buffer. If we should do something with the buffer, it takes all those objects and put them into various queues internally in the client to get handled. As we're processing the queue, we set a target for where the thing should ultimately go. And then every frame we essentially iterate over, every frame we linearly interpolate from where we are now to where we think we should go. And as we receive messages from the server, we're essentially frequently updating these targets. And so the end result is something that's pretty smooth. There's a little bit of jitter at the single client level. I'm going to see if I can actually run this locally. My keyboard has gone to sleep.
Yeah, it's certainly a big improvement over where it was before. When
Well,
we had a lot
yeah.
of
So
lag
what
from
happened
input
was
to actual action, right?
yeah, we did a scale test with like 6 people, maybe 8, and it was like unplayable because the lag was just so insanely high. And when I did some local testing, I think I ended up figuring out that like once you got above 6 or 7 players, the lag was like 1400 milliseconds of climbing. Like it just kept getting worse. Someday my keyboard will wake up. This is the one negative about Bluetooth. Okay, so let's try and run the server. Run and debug, play GD4. Right. Okay. So yeah, interestingly, so just one more Godot 4 sort of thing. Now that we are on Godot 4, settings, launch, play GD4. Yeah. So you can use this new core CLR build task thing that basically does like a pure .NET compile, like with the Microsoft compiler of .NET. It's so much faster. It's like zoom. So let's see, when I hit play here, run and debug, play GD4. 1, 2, 3, 4, like 4 seconds to compile this whole thing and build it and go. You can still do it the other way, but it's slow. Connection refused. Oh, that's because I am connecting to the wrong thing. Okay. So let's do this server config. Right, that server doesn't exist. We're going to go with localhost. I'm going to do this again. GD4. Where is it? There it is. Okay. So one thing of warning for those of you who are trying stuff like this, I think it's a Linux thing, but if this window is like not on the screen anywhere, it will drop to 1 frame per second.
Yeah, it gets backgrounded.
Yeah. So yeah, Linux basically backgrounds it when it's not literally foregrounded, which is somewhat annoying. But if it's like here, that's fine. So that's enough to make it happy. So now we're going to go to the client, which is probably going to play music. I'm going to go over here and then do the same play GD4. I'm going to pull this up. Scalable multiplayer game design.
Connection
What
refused.
happened?
It probably loaded any other configuration.
Yeah, no, this is also the same wrong server.
It's pointing
So
to the wrong place.
someday we'll have an error message that tells you that it couldn't connect, but at least Roddy caught it on the DL. Let's see, try this again. Server. Scalable multiplayer game design. So you can see here the client is reporting the processing lag as 0, which is technically true because it's basically ignoring everything that happens because it doesn't think that it's in the game. So fair. Okay, join the game.
That's client side lag.
Yeah, right.
Right.
Okay, so right out of the gate, no players except for myself on the server. Everything is running locally. Just for giggles, I'm going to do this. Does this show me the load average? It does. Okay. I'm going to try to put this in a place where you can see it, but I don't think you'll be able to see it. Oh, there we go. Okay.
This is
So
on the.
this is load on my laptop, which has like eight cores, 8 threads. So current lag is 67 milliseconds. Now, some of you are looking at that and going, that's awful, which is true. But remember, this is the lag from the moment the from the moment the server has sent the update to the point when the client is actually processing it. So it includes the buffer time, which we know is 50 milliseconds, roughly.
Right.
So it's really only like 15 milliseconds.
It's like
of
one
processing
frame.
time. Yeah, it's like one
essentially,
frame, right? Yeah,
Yeah.
exactly. So
would
I'm
this
go
be
ahead.
total response time? Like, is this from message goes out from the client, or is it just with?
This is just server. So
Just
this
server,
is the
yeah.
processing lag of updates from the server. So right now we are only receiving, right now we are receiving updates every 50 milliseconds or so. So roughly 1 frame or 2 frames, and processing them and then linearly interpolating the updates. So I'm going to start holding down the right arrow key. And what you'll see is, and I'm going to say now, and of course there's like live stream and all this other stuff, but you'll see there's a little bit of delay, of course, lag from the time I press the button to the time it starts moving. So now, and it took like a fraction of a second. And when I let go, it took a fraction of a second. But that looks smooth. I mean, like, considering that we're only getting a frame an update every other
It's
frame
pretty
or
good.
every, that's pretty good.
Yeah.
Now, there's one issue that I haven't figured out how to deal with, which is there's a little bit of like jitter
Yeah.
in the ship, and I'm not really sure why, but I haven't also spent any time investigating it. So that's the server, nobody else. So we've got processing lag 68 milliseconds with 1 player. I've got this add random button on the server that allows me to just randomly instantiate players on the map. So 1, 2, 3, 4, 5. So I've got 5 players that we know about. Lag has now gone up to 70 milliseconds. So we added 1, 2, 3, 4. We added 5 players and we picked up 3 milliseconds of lag, right? Because it was like 69, 65, and now it's like 71. So not bad. If you look here on the little radar, you can see there's other players on the map. Of course, I can't easily control them, but if I go move near one, we'll see it. So here's one of those other players. Now, the interesting thing here is that regardless of whether the other player is moving or not, right now we are receiving an update. And so there's probably even more size packing we could do by trying to be intelligent about, like, should we send an update about this player? Like, has anything meaningfully changed? Should we even include stuff? Like, whatever. Like, there's all kinds of interesting tricks that you can do. But I don't think we have like a bandwidth problem right now at this stage. Maybe when there's like a 500 players, we might, if we ever get to that many. So let's see, we're at 6 players total. So now let's go to 7, 8, 9, 10. So 10 players. I'm still at 70 milliseconds. Load average 158, 146. I forget what we're at. 2, 4, 6, 8, 10, 11. No, 10, whatever. Doesn't matter. Keep going more. I don't even know how many there are at this point. So, Roddy, I guess it's a computer issue for you.
Well, it's also the fact that you have one GUI for your server interface, and I had 14 graphical clients running with 14 independent.
Oh, yeah. So you
processors
were destroying your machine with these windows.
That's right. But clearly it was not the networking that was slowing things down.
But that's actually really good information, right? So
it's a good comparison.
I need to add a message or a thing that shows how many players there are. But there are a lot of players right now. 2, 4, 6, 8, 10, 12, 4, 13. I'm just going to keep pressing the button until something bad happens. Okay, that's a lot. So, like, look at that radar. I mean, there's a lot of stuff going on.
It's very busy.
71, 69, 68. So we have fixed the lag problem in the context of just the message update infrastructure.
Yep.
Now, with 30 people sending commands and TC... Oh, what is that?
Right.
Oh, I'm not in this
Because right now these players aren't actually doing anything, even though we are getting their updates about where they are in the world.
Right. True. They are not sending commands. So the flip side of this is that the game server has to receive all these updates. Sorry,
right.
I shouldn't use the word update. It has to receive commands from the clients, which are going to have network and processing and other overhead. So when we do an actual real scale tests with like real players doing real things, there will be messages that are being sent. So there'll be more network overhead on the actual debug server itself. Where is?
You should be able to zoom out there, right? In your
Yeah,
server console.
I think it's just broken, to be honest.
Like with the scrolly wheel, you can zoom in that. I did find when I used it last that it didn't always do so uniformly, but it sort of worked.
Yeah, but it's like I don't know where it is focused right now.
Ah.
There's also like right click to move the whatever, but we're just like off in God knows where space.
Yeah.
So oops, that's bad. Oh, okay. Here's a perfect example, right? So I backgrounded the
Oh yes, and
server.
the lag jumped way up there.
Sorry.
So
So
went to sleep.
on both sides. So, but this is actually interesting. I backgrounded the server and it killed the lag, and then I backgrounded the client and that killed the lag. But look what happened. Like it got to like almost 10 seconds of lag, but then it was just like zoop, it fixed
And then
itself.
it came back. Yep.
So I don't know, man. This is pretty cool. I'm actually more excited. I was really concerned, Roddy, when you told me that like it didn't work so hot.
Oh, with the 14 clients. But yeah, like we said, it seemed to be simply those running 14 graphical interfaces.
Yeah.
Via Godot, right? And I think each one of those took like 30% of a CPU.
Oh, geez.
Right. So this box is 6 cores.
We should build some command line, just like little AI players that we can.
Well, so that's a brilliant suggestion, and it's one that Roddy and I had been talking about. So there's a couple things we could do. So one is like just legitimately create a command line tool that just randomly moves a player around, like literal random. The other thing that I thought about was like, well, what if we sort of trained an AI? Like we have a messaging system, we could record a player playing, and then just like play that back as like real input, because that would be realistic in the sense of pressing the buttons like when in a reasonable sequence. Like, so as an example, I'm going to accelerate, but then I'm not going to accelerate anymore. I'm not going to like send a random accelerate command and then send a random decelerate command and then send a random right arrow and then send a random right arrow. Like there's going to be, sort of reasonable whatever. So building some kind of actual AI, air quotes, even if it's non-interactive, like if it doesn't care about the state of the system, it's just sending commands. But like we want those commands to look like real network traffic. Does that make sense?
Yep.
Yeah, I don't think that'd be too difficult to do. I did that for like this Xbox game I wrote several years ago, where basically I just had a class and like a few different personalities for the AI, but they had the same base class, so they could watch the same things, messages coming in. They could just like, they had a goal essentially. Their goal was, one of them was like, I'm like I want to shoot everything I see kind of goal. One was like I want to run away from people kind of goal.
Yeah, but I mean that's even more sophisticated than what I'm talking about, which is just like
it could be even simpler. Yeah, the base.
Yeah, literally just like play back a recording of player input, regardless of where you get instantiated on the map. You know what I mean? And so it's just like player gets instantiated, like, okay, 3 seconds in, we received some messages to speed up, and then they turned left, and then they fired a missile, but there's nothing there, but who cares? Because that's what they did. You know what I mean? Like legit, just like VCR playback of a stream of messages from an individual client. And there's got to be a way that we can do it pretty easily, like just write the binary stuff to a file, and then just like
read it in and fire it back.
Yeah, just read it in and fire them away. Yeah. I don't know how we'd capture the timing. There's probably a way to do that, but
it might even be just as easy, like I said, to like make it an AI that has a little bit like one goal, because.
And maybe there's a waypoint goal where the idea is to get to the point, right? And it just calculates whether it's pointing in the right direction, and if it is, accelerate. When it gets there, slow down and stop.
If you want to write the little client AI class
that would be really
switch
cool.
For that, you go for it, buddy.
All right.
We are super ready for you to do it, and we are super ready for anybody to participate, right? So as a reminder,
fully open.
srtgame.com. Like here's the website. It's got a link to some of the code. There's an interesting original thesis paper that we had read like a million years ago about doing scalable multiplayer stuff. A bunch of other references, a really outdated architectural design thing, but really links to the code. That's the important stuff. There's some issues that are targeted or tagged as like, good first issue, good for beginners kind of stuff. Like for example, putting a volume control and on-off button
Yeah,
in the
like a little
client.
GUI screen would be nice.
Yeah. And then another thing that we had talked about was right now the server debug UI is coupled to the server. So if I was to run the server over there headless, I can no longer debug because each server is trying to control the game. So even if I spun up a separate server, like there's no way to tell, we'd have to come up with a way to tell it to like just watch, like voyeur mode for the server or whatever, which actually would be the hackier, faster way. But then if it was in voyeur mode, like none of the commands you use to click the buttons or control stuff would work. So like we really need to separate
An independent and min kind of interface, right?
Yeah, like the
game.
debug UI needs to be its own interface, and then we probably need a special message queue
For
just
administration.
for debug administration
Yep.
messages. Yeah. But like it's interesting. We're at the point where now we have like real game design problems. Yeah, real problems.
How do you decouple the server so that you can, scale it out, right? We want multiple game servers, all headless. We want them running in, a data center somewhere, or
Well, we
AWS
need
or
to
the
get to the
cloud,
point where we can
right?
realistically understand how the game will perform at like we need to find where the scale problems are at this point. And so now we have the problems that come in commonly for a lot of multiplayer game projects where it's like, how do I simulate load? And so that was the conversation about AI. Like,
Right,
okay, well,
exactly.
it's not enough just to have a bunch of players just sitting there. Like we need commands to be coming in, and missiles to be firing, and the server has to be calculating all this other stuff. Like where is the elbow on number of players, number of missiles, like how many like commands coming in? Like at some point something's going to get ugly, and then we have to iterate. Like, okay, well, can we just send should we do some AI in the client, not even necessarily AI, but like intelligence in the client to know how long a player is going to rotate their ship for, or something like how do we reduce the number of messages that the client is sending for control updates and blah, 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 like all that kind of stuff.
Yeah. And another thing that kind of is flipping through my mind as we talk about like growing the server out and having more clients is like when we're measuring that lag right now, I think it works really well because you're on the same machine. We don't have to like sync the clocks from the different machines. So if we have multiple servers though, that have their own clocks, and if their clocks are different from each other, our metrics aren't going to give us the right information.
Unless you make sure they're all synchronized.
We have to synchronize.
At some point, when we get to needing a second server, we would need to, as you suggest, come up with some clock synchronization scheme, which honestly is on the surface isn't super challenging. But we've also have to figure out other things that are even more complicated, like, okay, we have a second server now. How do the servers decide which players are controlled by which server? How do we decide when a player switches from one server?
Yeah, that's right. What's the area
another?
of interest for a given server, right?
Yeah, so this I don't know if the shooter games are doing this now yet, but there's a bunch of stuff where it's like I don't care about things that are happening over there because I'm over here and I can't hear them, I can't see them, like they don't impact my environment.
Outside of my hex, I don't care.
Yeah, right. So like how do we figure out how to do those kinds of things? And we're not there yet. I have a feeling this game is pretty lightweight. Like we could probably have hundreds of players without like having to need a second server.
Probably, yeah.
Needing or wanting.
We're not sending a ton of data back and forth for any of the.
It's the server. Oh, did the server output any of that stuff? I think it did. Here's the server's log.
So Jason, were you thinking of something like the precision time protocol? Like, is that a thing for network synchronization, like within OpenShift customer land, like?
Oh, I mean, I kind of agree with Eric. I don't think it needs to be like the super hardcore, like we're running like a a simulation environment and we have to sync to like these massive clock speeds. I think it could be like a basic,
like NTP.
yeah, it could be
Just
something.
ensure
I
NTP goes
thought I
from the same
used to
source
have.
on the same network, maybe, right?
Yeah.
Yeah.
I've actually been reading this really interesting book. I don't know if you guys have read it before. It's called Designing Data Intensive Applications.
Nope.
And there's like all kinds of sections around like really detailed, like when you need to have clock synchronization at like high scale. They talk about stuff like that and different techniques you can take.
Designing
So
data
I
intensive
realized
applications.
what I did, just to change the subject real quick and then go back. I do have a message where it was talking about how many bytes it was sending, but it was in verbose only because we send an update like quite often. So it was really spamming the hell out of stuff. And there's actually a lot of messages I could probably turn from debug to verbose. But anyway.
Jason, was that the O'Reilly one?
It is an O'Reilly book, yeah.
Okay, by Martin Kleppman.
Yeah. Yep.
Okay, I'll just post
There
the
you go.
link
That's
in
a
the
good
chat
link
here.
for the chat. Yeah.
I hadn't seen that one.
Oh, Roddy, you're posting it from your own chat, your own Twitch
Indeed.
account, and okay. So none of those messages went to YouTube.
Oh, unfortunate.
It's all right.
I didn't realize that.
For the future,
I forgot
we got to use the chat and the.
Gotcha.
in the
Because it.
So for those of you who might be seeing this on YouTube, I apologize. If you've
Oh.
managed to watch this long, I will try to get the. Roddy, can you chat me a copy pasta of all the links?
Yeah,
I will
I'll
make
drop
sure
them
to
in the
edit
private
the
chat.
YouTube.
Got it.
Yeah, I'll
And
edit
put
the
them in
YouTube.
post production.
Yeah. Fix
Fix
it in
their
post.
mistakes.
Fix it in post. That's Chet's job. He's gonna fix it in post.
Alright.
Any other? Is there anything else we needed to cover today? We covered interp. We covered Godot 4 update. At some point, we're gonna do a live play session with all the viewers, and it's gonna be an absolute train wreck, but it's gonna be awesome.
Gonna be an entertaining train wreck, of course.
Entertaining train wreck. Yeah. Because we have it set. I mean, the auth does work. It will tie into your GitHub. There's a nasty bug right now where if you get blown up and you click the rejoin button, the server receives another join message about a player it already knows about, or something, and it's just like the server literally crashes, like segfault crash. So I got to fix that somehow. I don't know what the actual problem is, but it does that.
Dope.
But once we fix that, it'll be.
And when I had all the clients running, I was able to reproduce a different missile problem than in the past. Because the previous missile problem was it would launch, it would go, and then it would just.
If you were touching another player,
right, there was this weirdness.
Something weird would happen with the missile, yeah.
And now
which I was not able to reproduce.
And there was still something weird where I ended up with like missiles that were just sitting there. It was different. Like I remember that the behavior looked similar, but the steps in recreating it, I don't think were the same.
Yeah, but these are like the interesting fun problems that we can now have, that we have like a real playable game.
Yes.
So it'll be interesting to find some of those problems. I actually just had an interesting thought. So as of right now, like there's no points, there's no score, there's no whatever. It would be interesting to put like a timer above the player that shows how long they've been playing. So
Right.
It's kind of like other people would want to go after the person that's been around a long time, only for the fact that they've been around a long time.
Or maybe you get a score bonus, you know?
Well,
Maybe
at
like a
some point
sliding
we'll have to have
scale of-
score and some
That's right.
stuff, you know. But anyway, Chet's bored. He's like, I'm done
Kill
with
your
this
elders.
conversation.
Your
I'm done
age.
with this
I like that.
conversation.
How long you've survived.
Like King of the Hill, like.
sort of a survival.
Totally. I mean, well, we kind of had this battle
That's
royale-ish
right. We did.
idea, but with a persistent environment.
Yes.
So
The other thing,
Anyway.
game design wise, I don't know if you guys have talked about this in the past. I was like,
we have not
are
talked
there
about
going
much
to
design
be
lately.
like collectibles or any sort of like other things on the map besides players shooting at it?
I think some kind of power-up random spawn thing.
Yeah, we
would
talked
be
about how
cool.
the ship would kind of collect. Like when you
Well, that
destroy the
was-
ship, there'd be weapons that spawned off, and they would kind of accumulate.
Yeah, two different things. So one old design concept that we had talked about back with Derek back in the day
Yes.
was like exactly what Roddy said. As you destroy other ships, like random power-ups would get dropped, and as you collected things, like your ship would get bigger and heavier, and slower and like push towards the center of the map. And so that's kind of the time indicator, if you will. Like anybody that's closer to the center has been around longer because inevitably they're probably heavier. And then the other idea was just like the pure random power up, like Star Control Origins implemented, like just random power-ups, boosters appear on the map. So it's like your missile reloads faster, your ship is faster, your missile's faster, you get a gun, laser, whatever. There's all kinds of things we could try, but it's one of those things where like, let's get some scale and function and like fix the nasty bugs and then be like, okay, like how can we make the game more fun? Like, okay, what about this type of power up? Oh, that's terrible. Like, let's not do that. Okay, what about this power up? Oh, that's awesome. Let's do more of that.
I like it. I like how it's evolving too. And like, I don't know if we do create a community and people watching want to come be a part of like the game design process.
Yeah, that would be really cool.
Yeah.
Well, if anybody is still watching, which is unlikely, it would be great to have more participants, more community, more whatever, and this is a very common challenge with open source, which is like just having your code on GitHub doesn't mean you have a community.
That's right.
Like we need other people to be interested. When we get to the point where there's a lot of people, it's like, okay, then we got to talk about governance, right? Like, okay, we can't, 1,000 opinions being yelled loudly doesn't for a better thing make. There's got to be a way to filter and vote and all kinds of other stuff. So I would love to have problems of governance, on this project. So cool beans. Other thoughts as we get close to the end?
None here at the moment.
No? All right. Well, if you're still watching, thanks very much. We'll try to get some of those links into all the right places. If you're not watching, you're not going to hear any of this anyway. So see you later.
All right. See you, folks.
All right. Bye.
Bye, everybody.
Let's see what we got here. I know there's a button somewhere for something interesting to happen. Aha!
Go down.
Ending. There we go.